Hello everyone, in this video I want to using the first case to demonstrating how you can set up your problem statement to learn linear programming, and using later on we're going to using the graphical method and Excel solver to solve this problem. Okay, so it's very important when you work on leveraging the linear programming method to solving the optimization problem. You have to be able to, based on the case description, identify your objective function, your decision variable, and also on the decision constraints. So I think in any business decision, those are the very important element you need to understand. What is your objective? What are the lever you can pull? And of course, what is your limitation, right? So therefore, let's look at this case together. Abigail Kwan is an operation manager at the Fashion Tech, a manufacturer of clothing for family with an active and outdoor lifestyle. One of the difficult decisions that Abigail has to make every winter season is to decide how many parkers and winter jacket for women to produce. Okay, a lot of information in this first two sentences. However, you understand that for Abigail's decision making, she will mainly focus on how many parkers and a winter jacket the company to make. So there is a choice between parker and a winter jacket, and we need to help her decide how many. Okay, let's continue reading. Both products use the same material and require very similar sewing and stitching skills and manufacturing steps, and therefore compete for the same resource. She started by focusing on analyzing data for the medium-sized jacket and parkers. The amount of the machine time needed to produce a jacket and a parker are 1.5 hours and 2 hours, respectively. A tailor usually spends about 2 hours on sewing and stitching for a winter jacket and about 3 hours for a parker. Fashion Tech has a monthly contract with its supplier to produce 4,000 feet of the required fabric. The amount of machine time allocated to producing the two products is 650 hours per month. And each month, a number of the skilled tailor are assigned to this product to approximately 900 hours. Okay, after reading the following sentence, you actually realize it's talking about two resources that are the constraint for Abigail decision making, right? So one is the time that allocate to the machine. The second is the time the tailor can have to do the sewing and the stitching. And we'll also understand for each kind of product, in order to produce them, they use different amount of the time of the machine time, different amount of tailor's time. So for instance, for the jacket, it will need a 1.5 hour for the machine time, and for the parker, it need a 2 hour for the machine time. And for the tailor, need a 2 hours for the sewing time and a 3 hour for the jacket. They need a tailor's 2 hours time, and for the parker need 3 hours from tailor's time, right? And then also we know for these two resource, the time of the machine, the time for the tailor, they have upper limit, right? So for the machine, it cannot be over 650 hours, and for the tailor's hours, it cannot be over 900 hours, right? So now we identify there are two constraints by reading these 4 sentences. So let's keep reading. Historically, Fashion Tech has never sold more than 400 jackets and 150 parker in the month. So what does that mean? That means they really don't need to produce more than what they can sell, right? Otherwise, it's going to become inventory. So therefore, there's a two more constraint. That is, the jacket, the amount of production of jacket should be less than 400, and the amount of the parker produced should also less than 150. So after, at this point, you understand, in this problem, we are actually able to identify 4 constraints besides the non-negativity constraints, right? So we have 4 besides non-negativity constraint. And then, so the question is, what is the objective function? So for this business, since they are making the product, their goal is try to maximize their profit. But at this point, we haven't got a chance to gain the information about profit. So we haven't got any information about profit yet. Therefore, we keep continuing reading. Abigail also learned that the profit per jacket is $9 and the profit per parker is $150. Now we got the information we're looking for, right? So basically for this problem, Abigail will help the business to maximize the profit and facing 4 constraints and also non-negativity constraints. So let's just lay out everything on right down in the piece of on the Word document so that we can tracing what's going on here. So as I already designed the question following 6 question, actually just like step by step to guiding you through to solving this optimization problem. Okay, so the first is, what is the objective of this problem? Okay, so how can we use, we are not only just like, let's look at, we just write a sentence, the Abigail try to maximize the profit. So that's actually not, we are looking for that simple, because we have mathematical numbers. We want to incorporating them to help us to lay out how this mathematical model should look like. So therefore, let me pull out, open a, have a clean Word document ready. Okay, let me zoom in. So question number 1. What is my learning, what is the object function for this problem? So the object function for this one is maximizing problem, right? Maximizing profit. So the question is how my profit should look like. Okay, before getting to the profit, I need to really to actually define my decision variable a little bit before I move on to my maximizing profit. So let's see, I will name the P as Parker, as the number of Parker, and then the other one is J as the number of winter jacket. So it's a very important step to define your variable before you jump in it, right? So now we define P as the number of the Parker and J as the number of the winter jacket. They will produce. So for the profit maximization problem, let me go back again. Since we know the profit per jacket is $9 and then profit per Parker is $125, so in order to figure out how you formalize the jackets, so that's will equal to 9 times J plus 125 times P, right? That gonna give you profit. Okay. 9 times J plus 125 times P. Okay. So now this is gonna give me the value for the profit. As I said, here is maximizing this profit. So this is my objective function, maximizing J, 9 times J plus 125 times P. Okay, question 2. The question number 2 in this problem is asking you for what are the decision variable. So sometimes students get confused when they write down the decision variable. They will say, oh, Parker and winter jacket. That is not right. Parker and winter jacket, so they are just 2 items, right? So your decision variable actually is the number of the Parker and the number of the winter jacket they can produce. So your decision variable is not Parker versus jacket. It is the number of Parker will produce and the number of the jacket will produce. Okay, so it's very important you will define your decision variable. Again, P as the number of Parker produced, J as the number of winter jacket produced. So those are my decision variable, P and the J. Okay. Number 3. Question number 3. It is asking for what are the constraints. So again, any optimization problem will have constraints. So there's, as we read in the case, we learned that naturally we have 2 constraints, right? One is about the machine time. The other one is about the tailor's time. And then we also have the constraint in terms of we don't want to have inventory. We want to make sure we are not producing more than we can sell, right? So therefore we have 2 more related to the capacity of your market. So therefore, let's translate what we just read into mathematical formula, right? So first, let's just focusing on the machine time, right? So for the machine time, Parker needed 1.5 hour, and then the winter jacket needed 2 hour. What is the limit? So for the machine, they had the limit is 650 hour per month, right? So that is the limits. So therefore we need to type in, okay, one. So first of all, we need to ask ourselves, if we are producing, let me go back, P amount of the Parker, J amount of Parker winter jacket, how many hours that we spent, right? So that for the machine. So that for the machine time, so this is the first constraint. So that is for the P, Parker, for Parker, okay, Parker spent 2 hours, and then the Parker spent 2 hours, and the winter jacket is 1.5 hours. Okay. Hours times J plus 2 hours times P. Okay, make sure I didn't flip this. So 2 hours for the Parkers, right? 2 hour is Parker, yes. So this is how much time we will spend to producing J amount of the jacket and the P amount of Parker. However, this one has to be smaller and equal to that limit, right? So what is that limit? So the limit here stating is allocated to produce 2 product is 650 hours. So therefore that is my upper boundary, 650. Perfect. So the second constraint, so that is related to Taylor's time, right? So first of all, we need to identify in order to producing J amount of jacket, P amount of Parker, and how many hours the Taylor need to spend, right? So therefore we are reading the case again. Okay. So the Taylor usually spend 2 hours for jacket and then 3 hours for Parker. So therefore 2 times J plus 3 times P, that is how many hours we will use Taylor's time. Okay, Taylor's time, to make sure I type the number right. Okay, so for this constraint, there is a constraint, right? Because each month a number of the Taylor are assigned to this production is about 900 hours. So it has to be smaller than that availability of the resource, right? So this is the second constraint. Okay, so this is my first question, and this is my second question. This is my third question. And we're not finished yet because we also have the market constraint. So we also have market demand, right? So if you look at what is our market demanded in this situation, so we're talking about we never sold more than 400 jacket and 150 Parker. So therefore, it does not make sense for us to produce more than 400 and more than 150 Parker. So therefore, we need to add in 2 more constraints that's related to the market constraint, right? So therefore, come here, my J has to smaller and equal to, let me go back again, smaller and equal to 400. And then my P has to smaller and equal to 150. Okay, is that all done? The answer is no. We also have additional constraints, sometimes students forgot, called non-negativity constraint. So what does that mean? That means we understand since P and the J, they are both talking about the number of the product I need to produce. So none of them can be a negative number, right? So therefore, there is 2 more constraints. Sometimes students forgot. It's called non-negativity constraint. So therefore, P has to be larger and equal to 0. Similar for J has to be larger and equal to 0. Okay, here we go. So this is the answer for question 1, 2, 3. So once we set up my objective function and identify my constraints, all the constraints we have, and then we can first leveraging the graph, then the second leveraging the Excel solver to identify what is the optimum amount of the number of the park need to produce and the winter jacket need to produce so that we can maximize the profit. Okay. This is very important steps, and the students sometimes forget about identify correct amount of the constraints, so that's when the mistake will happen. Okay, so